I want to talk about these frequencies, and this is this frequency column here for just a moment. And you'll notice as we look in this frequency column, you'll see a couple of numbers recurring, 2.4 gigahertz and 5 gigahertz. Now gigahertz is million cycles per second, and so this is pretty fast. These are pretty high-end waves. These are up in actually the microwave area, but I want to show you why and where these are in the spectrum of the frequencies that we have regulated. 2.4 and 5. I'm going to look at this chart over here, and oh my goodness, what a busy chart. And it's so small it's hard to read. This is actually a quite high resolution chart, and I want to show you, I'm going to be pointing out this little amateur area right here and then on the chart itself. But I'm going to pause the video while I make this thing bigger, because it's going to take a little while for it to render that higher resolution. So I'll be back in a moment. Okay, we're back again. Now I'm going to bring this down, and we're going to be looking at this amateur section here. So what I want to do is go to, let's see, 3 gigahertz. Well, we said 2.4, so we got to go up to this row up here and over near the end till we get to about 2.4 gigahertz, which is right in here. And now you can see those 3 little bands here of amateur. So this is basically unlicensed, so that anybody can use it, and this is why we chose this area to put things like cell phones and cordless phones and Wi-Fi and Bluetooth and all that into this area here, the 2.4 area. Now if we go down here to the 3 to 30 gigahertz and we look over here around 5, well, we don't see anything around 5 here, but if you look up here in the 5.8, this is what we really mean by 5 gigahertz. It's in this range right here. Now I want to make another point while we're back here, and that is that when we have lower frequencies like 2.4 million cycles per second or gigahertz, we can carry less data on that slower speed of cycles, because you don't have as many cycles of ups and downs that you can put data into. So we can carry a lot less data on those, but because they are longer waves, they penetrate barriers a whole lot, and they can carry further. So you can get into that back bedroom of your house, for example, maybe with 2.4. But then when we get up into the 5s, now this can carry a really high data rate, but you can't carry it as far. It's more hampered by obstructions. So doors and walls and things absorb that energy a lot more easily. But if you can get it, you can get a whole lot higher data rate out of it at these higher frequencies. And that's a general rule. The lower the frequency, the less data you can put on it at a time, but the farther it travels. And the higher the frequency, the higher the data rate you can put on it, but the less distance it travels. So it all depends on what you're trying to accomplish when you're choosing which one to use. So device manufacturers will choose, or I should say those who create the standards, choose based on what they're trying to accomplish with that standard.